Let's talk about graphs of equations. Graphs of equations are drawn on the coordinate plane, and the coordinate plane is something that looks like this. So we have an x-axis, the number line, that goes to the right, and we have a y-axis, another number line, that goes up. And you could mark xy coordinates on the xy plane. So, for example, I'm about to mark some coordinates here. The point 32 means go 3 units in the x direction and 2 units in the y direction and land here. So this is the point 3, 2. Now there's a little bit of a conflict of notation. We've also used this similar notation for an interval, but in this case we're using the soft parentheses and the coordinate pair to denote a point in the xy plane. Whether or not this is a point or an interval should be clear from context. So for example, here's the point -1, -1. There are 4 sections, 4 regions in the coordinate plane, 4 quadrants. This quadrant in the top right is quadrant 1. And then you label the quadrants going counterclockwise. Quadrant 2 in Roman numerals, quadrant 3, and quadrant 4. You can think about distance in the xy plane or the coordinate plane. So the distance between 2 points, x1, y1, and x2, y2, is given by the square root of x1 minus x2 squared plus y1 minus y2 squared. So for example, I can calculate the distance between these 2 points. So for example, the distance between these 2 points is the square root of 3 minus -1 squared plus 2 minus -1 squared. What would that be? The square root of 4 squared plus 3 squared, the square root of 25, which is 5. Where the distance formula comes from should not be a mystery. It simply comes from the Pythagorean theorem. You could draw a triangle. You could draw a triangle this way, and the base of the triangle is the distance traveled in the x direction. So the base of the triangle in this example is 4. That's why I have a 4 squared. And the height of the triangle is the difference in y values, so 3 squared. And so using this right triangle trigonometry, the Pythagorean theorem, I get the length of the hypotenuse, that's the distance between these 2 points, in this case is 5. So we're going to draw graphs of equations in the coordinate plane. What is a graph of an equation? So the graph of an equation is simply the points in the plane that make the equation true, so that satisfy the equation. Now, let's do some examples. Let's say I have the absolute value of x equals y. So I'd like to plot the points in the plane that satisfy this relationship. So I could draw a little xy plane. There's the y-axis. Here's the x-axis. And to figure out what the graph looks like, I can randomly select points that satisfy this relationship and plot them. So for example, I could see that 0 for x and 0 for y make the equation true. If I take x to equal 1 and y to equal 1, the equation is true. If I take x to be negative 1 and y to be 1, I have a point on the graph. And you could plot a bunch of more points. That's my best advice for you. If you don't know what the graph looks like, either plot this in graphing software on a machine, a computer, or just plot a lot of points, which is essentially what the machine does anyway. So you could plot a lot of points, and in this case, I think you'll find the graph of the absolute value function looks like this V. Let's do another example. Let's do another basic shape, a parabola. So the graph of, actually let me just write down the equation. Y equals x squared minus 4x plus 3. So let's draw our x and y axes. There's 1, 2, 3, 4. Maybe the height is 1, 2, 3, negative 1. Now to plot this function, you could, of course, plot a bunch of different points. Plug in various x values. For example, if x is equal to 0, so if this x-axis up, if I'm at 0, the height y would be 3. So this point is on the graph. Alternatively, I could factor or use a quadratic equation to see that this equation can be written as x minus 1 times x minus 3. This gives me interesting points to plug in. It says if I plug in x equals 1, I get y equals 0, so that means I'm here on the graph. If I plug in x equals 3, I also get 0, so I'm here on the graph. These 3 points do not give me enough information to draw the graph, so more points the better. If I plug in x equals 2, I think I will get negative 1. If I plug in x equals 4, I believe I get 3. You could plug in a lot of more points, or you can remember from your mathematical background the basic shape of a quadratic, a parabola function, looks like this. So there's a sketch of the graph shown here. I'd like to do one more classic example. So we've seen the absolute value function, we've seen a parabola, a quadratic graph. I'd like to graph a circle. So how about this example? What about the equation x squared plus y squared equals 1? This is the graph of a circle, but why is that? You could rewrite this equation by taking the square root on both sides. The square root of x squared plus y squared is the square root of 1, or 1. Or I could even write this as the square root of x minus 0 squared plus y minus 0 squared equals 1. And that's starting to look a lot like the distance formula, how you find distance. I'm doing the same kind of operation. In other words, this equation says I'm thinking about all xy pairs that are a distance 1 away from the point 0, 0. So these are all xy that are distance 1 away from 0, 0. And if you think about that for a minute, you get a circle. What points are 1 unit away from 0, 0 at all times? I mean, well, that's got to be a circle. So here's 1. Here's 1. Graph of a circle. Let's finish this video with one other example of what a circle's equation might look like. So how about x minus 1 squared plus y plus 2 squared equals 9. I could do the same trick. I could take the square root on both sides. If I did that, this would become 3. So 9 is 3 squared. And on this side, I would see that I'm thinking about the points x, y that are a distance 3 away from the point 1, negative 2. So this is a circle of radius 3 with centered at 1, negative 2. So you could try to draw a circle with these properties. Okay, so there's a very quick introduction to graphs of equations.